Hi, I'm Darren and welcome to Level Up EE Lab. Well, I've been working on my Heathkit AV-3 meter and I've made some great progress. Let's check it out. A significant cosmetic problem that I need to address on this AV-3 is this large gash on the right side of the case. Now, I said a few weeks ago that I'd be looking for a parts unit at the Dayton Hamvention, and I got lucky. No, I didn't find another AV-3, but I did find this beat-up Heathkit V5 multimeter for only $5. Let's give it a ride on the old turntable and check it out. It clearly has not been well cared for. It's got a lot of dirt and gunk on the front panel, and the case has some rust on it. Let's take a look at the inside, and judging by the two mismatched screws, I'm likely not the first person to pull the cover off. Actually, the inside doesn't look too bad. Both tubes are still present, and it looks like it hasn't been modified. And check out that Burgess battery. Now that's a nice vintage touch just by itself. Now you've probably figured out the obvious by now. I didn't buy this V5 to restore it. I'm going to pirate the case to use for my AV-3. Heathkit used this style case for a couple decades for several of their kit products, including the AV-3. So this case will fit nicely to my AV-3 and save me from having to repair that gash. Looking more closely at the rust, it does appear to be only on the surface and not going through the metal, so that'll be easy to repair. Now I'm not going to throw out the rest of the V5, I'll save it for parting out for other projects, or maybe some other future idea. So with that problem solved, let's jump now to the new amplifier. Recall from the first episode that I said that all the original vacuum tube parts had been removed and there was a more modern LM324 op-amp circuit in its place. I decided to remove that too and substitute this new design that I'm using courtesy of Rod Elliott. Here's what the final layout of the board looks like. Overall size is 37 by 52 millimeters, so it's pretty compact. I've put all of the SMT components on the top side, and all the through-hole components like the electrolytics and the 3 trim pots are on the bottom side. I did go 2-layer with ground planes on both sides and only a couple of signal traces on the bottom layer. KiCad does not have a 3D model for the Borns 3362P trimmers I'm using, and I didn't want to create one, so just use your imagination. They'll go where you see the triple holes. I designed this board for home etching, which means there won't be silkscreen or any plated vias. So I put some legend text directly in the bottom copper, and for the vias that stitch the ground planes together, I'll solder in stubby jumpers. And here's the finished assembled board. I had no issues during etching, plating, and assembly, other than one small area of ground plane where the toner didn't transfer, but it was inconsequential. The two mounting holes are spaced 27 millimeters apart, which is arbitrary. There's no existing 27mm hole pattern on the chassis to attach it to, but finding and drilling a spot should be easy. There's plenty of room. I confirmed that there were no shorts on the board, so I powered it up and set the FET drain voltage. With a 9-volt supply, there should be around 5 volts at the drain. Now you set that voltage by adjusting the 10K trim pot at the FET source. Now, that's easier said than done. I don't have a spot on the board to clip on a test lead, so it takes a bit of back and forth between adjusting the trimmer and probing the board, but eventually I got it set pretty close to 5 volts. And with that step done, it's time to put some AC into this bad boy and see what it looks like after I set the linear calibration. Alright, it is lab time. I've got this set up here to show that the circuit is working, so let me walk you through what all this equipment is doing. First of all, I did build the attenuator on a breadboard. Now, of course, in the actual AV-3, it'll be on the back side of the rotary switch, but for now, I just laid it out linearly on the breadboard. Here's the amplifier board right here, and it's powered by my Heathkit 2718 power supply in the background here because I needed both 9 volts plus 9 volt rather, and minus 9 volt DC power. Here's the AV-3, of course, and you can see it's working. And the rest of the setup, I've got my Simpson 420 up on top here. That's function generator set for a sine wave output at about 600 hertz and about 1 volt peak output, or 2 volts peak to peak. And it's connected to the 1 volt input on the attenuator. Now the master here, the referee, is my trusty Keithley 177. That's what I've also got connected to the output of the Simpson function generator, and that's what I've calibrated the AV-3 against. Now, If you look at the specs on this Keithley, even though it's decades old, it's pretty darn good. 10 meg ohm input impedance, of course. Its factory specs were plus or minus 0.5% plus 15 digits true RMS measuring AC. I don't have it recalibrated, but certainly it's good enough for what I'm trying to calibrate this analog meter to. And of course, I got the 2465 scope. That's mainly just there for show so we can see what the signal looks like. As far as the rest of the connections, I am doing a good practice here of having a star ground for everything. So that means the amp board, the AC3 meter, the Simpson function generator, the Keithley, they're all connected to ground at a very, very close point here on the breadboard. And I've got the output of this function generator and the Keithley connected very close to each other too, to try to eliminate any ground loops or other signal corruption there. So I have done the calibration already per the instructions in Rod's documents, and actually things turned out really good. So let me demo this as I adjust the magnitude of this signal generator. Watch the Keithley output versus the analog meter, and I'll try to pause these at points on the 1 scale. So not the upper scale, but the lower scale that goes up to 1. So here we go. And of course, it's a little hard for me to get the needle aligned off to the side, but I think you get the idea. So I'll put it at 0.8 just for reference, and 0.807 on the Keithley. And that should be pretty close to full scale. So like I say, the tracking's looking really good. I'll show on screen now the actual calibration curve that I generated. And what I did is I set the output of the function generator at a magnitude to get to about every 10th of a unit reading on the AV-3, and then saw what the Keithley was reporting. And this is what it looks like when they're correlated to each other. So certainly they're tracking well enough. It's within 1% of full scale or better, which is plenty accurate enough for what I'm going to use the meter for. Now, the next thing I want to show is how the AV-3 now with this new amplifier responds over frequency. And what I'll do, and I'll have to move over to the left side of the camera, is adjust the frequency setting of the Simpson. And what I'll do, right now it's at 600 hertz, so I'll take it up to about 100 kilohertz, and we can see how it responds. Now, a couple caveats. This is all open, so we're starting to get some stray capacitance effects when we get up to higher frequencies, so that won't be the same as when it's all packaged. The calibration will be a little different once I put it in the case and power it off the 2 batteries. But with all that aside, I think you'll see here that it is tracking quite well over frequency, and it should drop off a bit. Last comment I'll make before I do it, because the Simpson output is not flat over that frequency range. But as this AV-3 needle falls, we should see a corresponding drop off in the Keithley. So I'll reposition myself to the other side of the screen, and we'll see what it looks like. Okay, so I borked up the audio badly for this clip, so I'm just going to do a voiceover. So here's what the response looks like when I vary the signal in the 100 Hz to 1 kHz range. And I'll also show the 1 kHz to 10 kHz range, and then the 10K to 100K range. What I said earlier about the signal drop off isn't right. The Simpson is actually pretty flat in output over these ranges. The AV response starts showing some drop off above about 50 kHz, which is fine for audio work. But I've also got the effects of all the stray capacitance of this breadboard setup, so I'll remeasure the frequency response once I've got the unit all put together. And the final thing I want to talk about today while I'm in the lab with this AV-3 is a mistake that I made when I hooked everything up. And like I say in my intro for Level Up EE Lab, I'm not bashful about showing off mistakes that I've made, just so we can all learn from some of the, sometimes the very easy gotchas that can creep into when you're trying to transfer, in this case, a circuit diagram to an actual breadboard and a physical layout. And the mistake was, and I'll show it on screen here, is there's a 1N4148 protection diode that goes across the input terminals for the analog meter. It's there to help shunt any overvoltage / overcurrent that the meter might see. It helps provide some protection, and it's supposed to go across the 2 terminals of the meter. The mistake I made is I put it across the 2 outputs of the amplifier. And in hindsight, that's a pretty easy and kind of dumb mistake to make, because if you look at the schematic, it's easy to think, well, the meter just hooks up to the output of the amplifier, and that's not entirely true. It's the meter plus the 4 germanium bridge diodes that are on the back of the meter. That's what connects to the amplifier. So what I ended up doing by accident was creating a new circuit path kind of in parallel with the output of the meter, and it's siphoned off some of the current, and it caused the correlation curve to be really wacky. It made it nonlinear, and it was off by almost 10% at full scale. I started to get worried that maybe I made a mistake in laying out the amplifier or did something squirrely there to really mess up the linearization, but it only took me a few minutes of double checking the schematic back to the way I actually wired it, which is always a good practice when you're setting stuff up in the lab. Look there first and see if you actually did something boneheaded, which is what I did. Once I put the diode across the 2 terminals of the meter where it should have been in the first place, then everything was good. I've got the electronics working very well, and so now the next focus on the project is all mechanical and finishing up the assembly, and I've got a jump start on that portion. I soaked the case components in rust remover and got rid of the rust that's on there, so now it's sanding, priming, and painting. I also have to paint the front panel, and I have separated it from the meter, and more than likely I'm just going to repaint it and put new graphics on there. I'm not quite sure exactly yet what format I'll use for graphics, but I got a few ideas for that. And then of course get it all buttoned up, do the final calibration, and have it ready for use. And all that will be the subject of the next and probably final video in this series. So as always, I hope you're enjoying this material I'm putting together on my channel, and thanks very much for watching. So until next time, bye for now.